For pretty much all of Earth's history, the sun has been our life-giving star. I mean, it's the source of everything. But let's be real, it's also a violently chaotic, constantly exploding hydrogen bomb. So it kind of makes you wonder, what would actually happen if you fell into it? Let's take that totally impossible journey and find out. So let's just suspend our disbelief for a minute. Forget about the how you'd get there. We're gonna focus on the what. If you could somehow survive the trip, what would you actually see? What would you feel as you plunged from the outer atmosphere all the way down to its fiery core? Okay, to pull this off, we're gonna need some seriously impossible technology. So let's just invent something. Let's call it the Viant suit. Think of it as our all-access pass, a magic shield against the insane heat, radiation, and pressure we're about to face. All right, you got your suit on? Let's do this. The fall begins now. Now, you might think this journey starts right at some fiery surface, but nope. It begins way, way out, millions of kilometers away in the cold, dark of space, where the sun's influence first really takes hold. When you get to about 7, maybe 10 million kilometers out, you've officially entered the sun's outer atmosphere. And this isn't an atmosphere like we have on Earth, not even close. You've just plunged into a region of incredibly thin but super hot gas called the corona. Welcome to the corona. This place is a total paradox. It is unbelievably hot, but at the same time, it's pretty much empty. The temperature here, a cool 1 million degrees Celsius. Now, that sounds like you should just be gone, instantly vaporized, right? Just a puff of smoke and a sea of fire. But you're not. At least, not yet. So what gives? How is that even possible? 1 million degrees, but you're not instantly incinerated. Well, it all comes down to a really important difference between temperature and heat. Think about it like this. Imagine a 70-degree sauna versus a 70-degree bath. In the sauna, you're fine, right? That's because the air has a really low density, so it transfers heat to you pretty slowly. But if you jumped into a 70-degree bath, that high-density water would transfer its heat instantly, and you'd be seriously burned. The corona, it's like a giant super hot sauna. The particles have a ton of energy, but they're so far apart, they can't really transfer that heat to you. But hey, don't get too comfortable. That low heat transfer might buy you some time, but the radiation is off the charts. We're talking over 200 times what astronauts deal with in Earth's orbit. And you'd have a front row seat to some incredible and terrifying sights. Solar flares, the biggest explosions in our entire solar system, and massive sunspots, which are actually cooler spots with magnetic fields so powerful, you would absolutely want to keep your distance. Okay, so as you keep falling, getting closer and closer to what looks like the sun's surface, something totally bizarre happens. Something that makes no sense. It doesn't get hotter. It actually gets cooler. Like, way cooler. Check this out. Up at 18,000 kilometers, you're in that million-degree corona. But by the time you're just 2,500 kilometers out, the temperature has plummeted to around 50,000 degrees. And when you finally hit what we call the surface, the photosphere, it's a relatively chilly 5,500 degrees Celsius. And this isn't just some fun fact for our thought experiment. This is a real, genuine scientific puzzle that has stumped scientists for decades. It's called the coronal heating problem. Nobody has a definitive answer for why the sun's atmosphere is hundreds of times hotter than its surface. It just doesn't make any logical sense, but it's true. Now, right as you hit this 5,500 degree layer, you'd feel something else, a crushing force. The gravity here is 28 times stronger than on Earth. Without our Viant suit, you'd be flattened into a pancake instantly. But here's the thing about this surface. It's not solid at all. The sun is a giant ball of plasma, which is just superheated gas. The photosphere is just the point where that gas becomes so dense that light can't escape from below it. There's absolutely nothing to land on. So you just keep falling. So you've passed through the photosphere. Now the journey gets really wild. You're going inside the star itself, starting with a 200,000 kilometer plunge through something called the convection zone. In this zone, heat is just churning around like water in a boiling pot. You've got these huge blobs of hot plasma rising up, cooling off, and then sinking back down in this constant, violent cycle. And as you fall deeper, the temperature starts to skyrocket again, climbing all the way back up to 2 million degrees Celsius. And that's when you reach the next layer, the radiation zone. And in here, things get even weirder. The pressure is just astronomical, 100 million times the pressure of Earth's atmosphere. The temperature keeps climbing. And then, even though you are inside the brightest thing in our solar system, your world goes completely and totally dark. How is it possible to be pitch black inside a star? Well, it's because the hydrogen and helium atoms in here are packed together so tightly. Any photon, any little particle of light that gets created, is almost instantly absorbed by a nearby atom. It can't travel even a millimeter before it's swallowed up. Nothing can get to your eyes. You are literally falling through a superheated, hyper-pressurized, absolute darkness. After falling for what seems like forever through 300,000 kilometers of that dark, crushing pressure, you finally made it. You've reached the final destination, the sun's core. This is the engine room of our entire solar system. The conditions in here are just mind-bending. The temperature is 15 million degrees Celsius. The pressure is 200 billion times what we feel on Earth. And the density is just staggering, about 150 grams per cubic centimeter. To give you some perspective, a chunk of solid gold is only about 19 grams per cubic centimeter. So this place is nearly 8 times denser than gold. And it's in this cosmic pressure cooker that the magic happens, nuclear fusion. That immense pressure and heat, it literally slams hydrogen atoms together so violently that they fuse and become a new element, helium. And in that tiny little reaction, a tiny fraction of their mass gets converted directly into a colossal amount of energy. That's the light and heat that powers our entire world. I mean, just stop and think about that for a second. Every single ray of sunlight that's ever warmed your face, every photon that's ever allowed a plant to grow, every bit of light you have ever seen in your entire life was born right here, in this impossibly hostile place at the very center of our sun. But those photons don't exactly have an easy escape route. The core and the radiation zone are so incredibly dense that a single photon, just born from a fusion reaction, will spend an average of 170,000 years just trying to get out, bouncing from atom to atom on this long, random walk to freedom. Our impossible journey in the Valiant suit took maybe a few minutes, right? But a single particle of light takes 170,000 years to travel that same distance from the core to the surface. It really makes you wonder, doesn't it? Which journey is the truly impossible one?